So now we will see this this example of a proper cantilever beam which has a hinge at this location. You see hinge is there at this location. Okay, in the span at B. Remember that one of the most important features of a hinge is that bending moment is always 0. So because support A is simple and allowing the full rotation, okay, and as the load causes the beam to deflect downwards, this load will cause the beam to deflect downwards like this, right? It will deflect downwards, and AB will curve and rotate. This will curve and rotate, and the shear load at C, shear induced at load C, will in turn BC is a cantilever. Okay, there will be a discontinuity in the deflected shape at this hinge. So the diagram shows the reaction and bending moment diagram. We will see how the reaction and bending moment diagram will come. Okay, so this you can imagine like one simply supported beam like this, and another cantilever beam something like this. Okay, you can imagine like this. This is the cantilever support, and this is the hinge location. This is the simply supported location. Okay, this is the load. Because of this load, what will happen here? There will be a compression on this element, right? So this will bend like this. This will bend like this, and this will bend like this. So at this point there is a discontinuity in this slope. This is the hinge location. It will act like a cantilever. It will act like a, this is acting like a simply supported, and this is acting like a cantilever. Okay, so in this example we will see that here this is the fixed beam with central point concentrated load. Here you can see this is the point of contraflexure. Alright, this location is a point of contraflexure. So point of contraflexure span is, we can say that from this point to this point, this distance is L by 2. Alright, L by 2, because this is L by 4. This is from this point to this point, and this point to this point is L by 4. So this can be simply made like one cantilever, and this is the simply supported, and another cantilever, and load is like this, right? So that means here this is the point of contraflexure, that hinge location. Because of this load P, there will be a P by 2 load, P by 2, and here also P by 2 in internal force on this compression member. So this can be taken as a cantilever with P by 2 load. So P by 2 into this span is, so how much is the span? That is L by 4. So L by 4. So bending moment will be force and distance, right? So P by P into L by 8. That's a moment. It will come like this, right? This is the moment. On tensile side I am drawing it. The same way for this cantilever also. So cantilever moment will be PL by 8. If you see this simply supported beam is the PL by 4 is the bending moment, right? PL by 4. But here L is L by 2. This capital we can replace by L by 2. So that means P into L by 8. That's the bending moment. So that means it will come, the bending moment will come like this. So overall the bending moment diagram, if you see in tension side, here we can see between the simply supported, it is the W L by 8, and to the fixed side, cantilever side, it's a PL by 8. Here also PL by 8. So this is how we can see this. We can use this point of contraflexure as the span between these two. It's like a two cantilever beams on simply supported beam. The fixed beam can be considered like that, because the point of contraflexure, we know it is L by 4 from this support for this point load. If you apply point load at center,